Hello students, today we will be studying the topic chemical equations in detail. Let us recall the activity 1.1 which we discussed in the previous lecture. अगर आपने पहले वाला lecture नहीं देखा तो just go through that, you will understand this thing better. तो activity 1.1 में हमने क्या किया था? When a magnesium ribbon was burnt in oxygen, it got converted into magnesium oxide. Okay. So if we describe this equation, like how this reaction took place in words, so this description of a chemical reaction in a sentence form is quite long, right? So there is a way to write it in a shorter form that we will be studying today. So the simplest way to do this is to write it in the form of a word equation, right? So the word equation for the above reaction, we can write it as magnesium plus oxygen. Through arrow, we represent that it gives magnesium oxide. So on the left hand side of the arrow, we have reactants, like the materials which are reacting together to give a final product. So on the right hand side of the arrow, we have a product. Okay. The substances that undergo chemical change in the reaction, that is magnesium and oxygen, are the reactants. Okay, and the new substance is magnesium oxide, which is formed during the reaction. This is a product. So just learn these definitions of reactants and products. The word equation shows change of reactants to products through an arrow placed between them. Okay, so you can see the reactants are written on the left hand side, LHS, with a plus sign in between them. Similarly, the products are written on the right hand side with a plus sign between them. So in this case, there is a single product. So if there are more than one products, we can just put a plus sign in between them. Okay. And the arrowhead points towards the products and shows the direction of the reaction. So arrow is very important. So it is pointing towards the products. So this equation 1.1 represents the word equation for the activity 1.1. Now we will see how to write a chemical equation. So is there any other shorter way of representing chemical equations? Okay, let's discuss that. Chemical equations can be made more concise and useful if we use chemical formulae instead of words. So in earlier slide we were using words actually, like magnesium plus oxygen. So instead of words now we will be using chemical formulae. So a chemical equation represents a chemical reaction. If you recall formula of magnesium, oxygen and magnesium oxide, the above word equation can be written like this. So Mg represents magnesium plus O2 represents oxygen here, then arrow is there, and then magnesium oxide is represented by MgO. So if we count and compare the number of atoms of each element on the LHS and RHS of the arrow, what do we find? See, there is one Mg here, one Mg on the right side. There are two O's on the left side and there is a single O on the right side. So is the number of atoms of each element the same on both the sides if we check, right? If yes, then the equation is balanced, and if no, then the equation is unbalanced because the mass is not the same on both sides of the equation. If we compare the mass on both the sides, it is different for oxygen here we see. So in this particular case, this equation is not balanced or it is unbalanced. So such a chemical equation is a skeletal chemical equation for a reaction. So in this particular case, it is a skeletal chemical equation for the burning of magnesium in air. It is not a balanced equation. In the coming slides, we will see how we can balance any unbalanced chemical equation. Is the concept clear? Now we are going to understand the balanced chemical equations. So let's recall the law of conservation of mass that you might have studied in class 9. So we studied that mass can neither be created nor destroyed in a chemical reaction. That is, the total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. Means left hand side पे जो आपका total mass होगा, that should be equal to the mass on the right hand side. It must not be unequal. So this is the law of conservation of mass, because we cannot either create or destroy mass. Mass has to remain same on both the sides of the arrow. Okay. Now, in other words, the number of atoms of each element remains the same before and after a chemical reaction. Means अगर आपका left hand side पे there are two oxygen atoms, so on the right hand side also you have to maintain two oxygen atoms. Otherwise, the conservation of mass law is not followed there. So hence we need to balance a skeletal chemical equation. आपको उसे balance करना पड़ेगा so that this law remains there. And if we check that equation was not balanced, like we saw in case of magnesium, so we will learn how to balance a chemical equation step by step. So let's take an example of the equation from activity 1.3, which we studied in the previous lecture. So in that, what was happening? Zinc plus sulfuric acid was giving us zinc sulfate and hydrogen. We saw there was bubbling due to the release of hydrogen gas. So this is the same equation for that. Now if we represent this in the form of a chemical equation, we get Zn plus H2SO4 gives ZnSO4 plus H2. So this is the chemical equation obtained for that. So now we have to check whether the number of atoms of each element is the same on left and right hand sides. So we create a table, we identify the various elements which are present. So we can understand zinc is there, so we fill the element as Zn, H is there, hydrogen, S, sulfur, O, oxygen. All these elements we fill out. And then we fill the second column with the number of atoms of the reactants as LHS and then number of atoms in products as RHS. So we see here one Zn atom is there. On the right hand side also one Zn atom is there. So we fill that one. Similarly, if we see for hydrogen, two hydrogen atoms are there on LHS and similarly two hydrogen atoms are there on the RHS. So we fill two here and two here. Next we see sulfur. Here only one sulfur atom is there. On RHS also one sulfur atom is there. We fill one and one. Last we see oxygen. Here four atoms are there. In RHS also four atoms are there. So we put a 4 and 4 here. As the number of elements is like same, atoms is same for all the elements, the equation we can call it as a balanced chemical equation. So no need to follow any steps here. Now let us see one more example. Again, a chemical equation is given to us. We have to check whether it is balanced or unbalanced. And if it is unbalanced, we have to balance it. Okay, same procedure we follow. We just create a table, identify the elements. So basically elements present are iron, Fe, hydrogen, H, oxygen, O. All these we fill here. Then we see the number of atoms on LHS and RHS. Let's consider iron. So here iron is having one atom and on the RHS it is having three atoms. So we fill here 1 and 3. Then hydrogen, let's check. Here hydrogen is having two atoms and on RHS also it is having two atoms. So we fill 2 and 2. Let's check for oxygen. Here it is 1 and on the RHS it is 4. So we write down 1 and 4. So if we compare the numbers in this table, we see that for iron, the numbers are different. For hydrogen, it's same. For oxygen, again, it's different. If it's different even for one element, the equation will be unbalanced. Okay, so we see that this particular chemical equation is not balanced and we have to balance it now, right? So how do we balance? So we have to balance every element one by one. So here let's start with balancing of oxygen. So oxygen we see on RHS we have four oxygen atoms and in LHS we have one oxygen atom. So what we do, we put a 4 in front of H2O here. So this chemical equation becomes Fe plus 4H2O gives Fe3O4 plus H2. Now let's check on LHS how many oxygen atoms are present as this 4 is written here. For 4 oxygen atoms are present on the LHS, and if we check on RHS, again 4 are present. So we can say that oxygen atom is balanced for this particular chemical equation. But this is not a completely balanced equation because other elements are not balanced, because we can see here now hydrogen has become 4 into 2, that is 8. We have 8 hydrogen atoms on LHS and only 2 hydrogen atoms on the RHS. So again we need to balance these also. So how we balance these? As we saw, like here 8 hydrogen atoms were present and on RHS there were only 2. So now we put a 4 here in front of hydrogen. So what happens on RHS? 8 hydrogen atoms are there, and on LHS also 8 hydrogen atoms are there. Now let's check one by one. Iron is 1 here, 3 on RHS. Hydrogen is 8 here, 8 on RHS. Oxygen is 4 here, 4 on RHS. So now only iron remains unbalanced. So for iron, what we can do, as here 3 iron atoms are there, we can put a 3 in front of this Fe. You can see here we have added a 3 here. So now here 3 iron atoms are there, and on RHS also 3 Fe atoms are there. So now this particular equation, in which all the 3 elements are having equal number of atoms on both the sides. So this particular equation is a balanced chemical equation. So this way in which we are just balancing every element one by one, this is known as hit and trial method. So in hit and trial method, someone can initially try to balance iron, someone can try to balance hydrogen. It's not like a particular steps only you have to follow. So this is a kind of hit and trial method to balance the unbalanced chemical equations. So this is a very crucial step now. We have to write the symbols of physical states. See, sometimes you are using iron. You know that Fe is written, you are using iron. But in what form? Is it solid, liquid, gaseous? Like how you are using? What is the physical state of that material? That we can specify in these equations by the help of notations. And these are the notations. We can use G for gaseous, L for liquid, AQ for aqueous, and S for solid state. So aqueous means suppose you are having the reactant or product as a solution in water, that is referred to as aqueous. So let's take an example here. If we see this equation, we have written 3Fe and within brackets we are writing S. That means this iron is in solid state. Water is in gaseous state. Fe3O4 is in solid state, and again hydrogen is in gaseous state. So, how water can be present in gaseous state means you have to provide it in the form of steam. It's not in liquid form. So you have to provide in gaseous form and steam form. Then only it will react. So this provides very crucial information if we write like this. Then certain other conditions of the reaction you can specify in these equations. These include temperature, pressure, catalyst, etc. So temperature, like suppose a reaction is taking place at 200 Kelvin or 40 degrees Celsius, that temperature you can specify on this arrow. Above this arrow, you can write the temperature. Similarly, pressure. In this particular example, we are showing the pressure as 340 atm. So this pressure can be specified like this. And any other conditions like we are specifying here sunlight, chlorophyll, these are catalysts. So what is a catalyst? Means anything that will speed up the reaction. It will make it occur fast. That you can specify on the arrows. So this is the way we can specify additional information in the equations. Here also we can see like this is gaseous, hydrogen is gaseous, this is liquid, CO2 is in aqueous form. That means you have made a solution in water. Then these two are in aqueous form, water is in liquid form. So all these information you can specify easily. So now I give you a small task. you can just try to balance this chemical equation. Try to balance this. This is Mg plus O2 gives MgO. As you can clearly see, we have one magnesium atom here, one magnesium here. Oxygen is 2 here, 1 here. So it is unbalanced. So try to balance this and post the answers in the comment section. And I'll just check and revert over that. Okay, so now again we have certain questions like write the balanced equation for the following chemical reactions. So, in this way the questions are asked in the exam, like in words they will give you like hydrogen plus chlorine gives hydrogen chloride, and you have to write down the chemical reaction for this, and that equation which you obtain you have to balance that. So this is the way you are given a question in the exam. So for that you need to have a very good practice, like you need to know the symbols. Like suppose we have hydrogen here. So you should know the symbol of hydrogen, chlorine. Then you should know the chemical formula for hydrogen chloride. For this you can practice it using class 9 books. In class 9 you might have learnt everything in detail. Like here, barium chloride, you should know what is the formula for this. Aluminium sulfate, everything. It should be on the tips. Like if you know how to write down the chemical compounds formula and all, this section is going to be really easy for you. So let's see the results for this. So here are the three equations for these, like hydrogen plus chlorine gives hydrogen chloride. So hydrogen we know it is H2, chlorine we know it's Cl2, and hydrogen chloride is HCl. So from where this 2 comes? This is after balancing. So this was initially unbalanced. So in order to balance it, we are adding this 2 here. Second one is barium chloride plus aluminium sulfate gives barium sulfate plus aluminium chloride. So barium chloride is basically BaCl2, aluminium sulfate is Al2SO4 whole thrice, then again barium sulfate is BaSO4 and aluminium chloride is AlCl3. So all the valency symbols and all, please revise it from the class 9 textbook. Learn the tables so that you don't face a problem here. And again it has been balanced, that you can do as a practice, and if you have any doubts you can post it in comment section or you can join the weekend doubt sessions. Third one is sodium plus water gives sodium hydroxide plus hydrogen. So sodium we know it is Na, water is H2O, sodium hydroxide is NaOH, and hydrogen is H2. So basically we get this particular equation and then we balance it. Let's try and check out if it is balanced. See, there are 2 atoms of sodium here, 2 atoms on the right hand side. If we count for oxygen, 2 oxygens are here, 2 oxygens here. Hydrogen, if we see 4 hydrogen atoms, we do 2 multiply 2, that is 4. And here we have 2 hydrogen atoms for NaOH and 2 from H2. So 2 plus 2, 4. So everything is balanced. Now, similarly, another kind of question you may face in the exams, this is the way it is written, it will be given in the form of sentences. So like first one is write a balanced chemical equation with state symbols for the following reactions. So state symbols also we have to mention whether it is solid, liquid, aqueous, gaseous, all these things we need to mention. So the question says like solutions of barium chloride and sodium sulfate in water react to give insoluble barium sulfate and the solution of sodium chloride. So we need to know the basic formula for like barium chloride, barium sulfate, sodium chloride, all these we need to know. And using those we can write down the equations. So let's see how we write them down. So here are the chemical equations. So barium chloride we write down as BaCl2. Then why do we write it as aqueous? AQ is written here because it was given solutions of barium chloride. So it is a solution basically. So in solution form we use AQ, and sodium sulfate Na2SO4, because this was also in the solution form we mention it as aqueous. So they react to give insoluble barium sulfate. So something which is not soluble in water. It is solid only. So we have mentioned solid here. And solution of sodium chloride, so sodium chloride NaCl, we mention it as aqueous because solution is given. So here basically we are mainly checking for these symbols. These symbols we had to mention. And again, we will check if it is balanced or not. If it is not balanced, we need to balance it. See, in final exams, marks are deducted if you do not balance the chemical equation. So always leave the answer in the balanced form only. Now, next one is sodium hydroxide solution in water reacts with hydrochloric acid. So we have this as solution. So we write NaOH aqueous, hydrochloric acid solution in water. So HCl also aqueous to produce sodium chloride, NaCl aqueous and water, H2O. H2O is in liquid. So this is the equation. So it is already balanced, so no need to balance this equation. Thank you so much for watching this video. And I hope like your concepts of chemical equations will become clear if you watch this video properly, and you need to note down everything. Just write and do the chemical equations. You will get better results using that. And for this you need to practice a lot. This particular section needs a lot of practice. I will be sharing some practice material for the students who are registering for the course, right? And we can discuss those problems in the doubt session that we conduct on Sundays. Thank you so much.